Welcome to The Explainer. You know, every single building you see, from a towering skyscraper to your local corner store, has a secret. It has an origin story, a reason why it exists right there, in that exact spot. Today, we're going to learn how to read that secret language.
It seems like a simple question, doesn't it? But the answer? Well, it's a fascinating detective story. See, architects and planners don't just throw a dart at a map. Nope, they conduct a really deep investigation, a site analysis, to uncover all the clues hidden in a piece of land. So, let's see how they do it.
All right, first things first. In any investigation, you have to choose where to even start looking for clues. For architects, this whole process kicks off with a really fundamental choice about the type of land itself.
So are they going to build on what's called a greenfield site? We're talking pristine, untouched nature here, like a meadow or a forest. Or are they going to take on a brownfield site? That's a place that's already been used, maybe for industry, and frankly, it might need some serious healing. This one decision has massive, massive implications for the environment and the community.
Now you might be asking, why would you choose the more complicated site? Well, deciding to redevelop these urban sites is so much more than just recycling land. It's an incredibly powerful, sustainable strategy. For one, it keeps our precious green spaces safe. It helps fight back against endless suburban sprawl. And you get to connect to all the infrastructure that's already there, which strengthens the whole community and saves an enormous amount of energy, materials, and landfill waste.
So once a site is picked, the real detective work begins. The investigators don't just glance at the land. They examine it through three distinct but totally interconnected lenses to get the full story.
These are the tools of the trade, right here. The investigators look through a physical lens, which is all about what nature's doing, sun, soil, things like that. Then they use a cultural lens to understand the human story, the history, the neighbors, and finally, a regulatory lens to check the rulebook. Zoning, building codes, you name it. You absolutely need all three to see the complete picture of what's even possible.
Okay, let's start with the physical evidence. This is the stuff you can actually go out and measure and map. Where does the sun travel across the sky? Which way does the wind usually blow? What are the slopes like on the ground? What's the soil actually made of? And where are the power and water lines buried? Even things like, what are the best views we want to capture? And where's that noisy highway we need to block out? Every single one of these clues directly shapes the final design.
Next, the investigators start to layer on the human story. What was this land used for before? Are there old foundations buried just under the surface? Or maybe even chemical spills? What's the neighborhood actually like? Is it close to schools, parks, public transit? These cultural clues, they reveal the site's past for sure, but they also point to its future place within the community.
You know, sometimes the most critical clues are the ones you can't see with the naked eye. They might be buried in the soil or hiding in the walls of an old building. This is where the investigation gets, well, it gets forensic. And it's done with something called an environmental site assessment.
On a site that's been developed before, investigators have to hunt for hazardous materials that might have been left behind. We're talking about things like asbestos, lead, and mold. Those are pretty common concerns. But also things like PCBs, that's polychlorinated biphenyls, which are really harmful industrial chemicals. Finding these things early is absolutely critical for safety.
And the process for finding them is very methodical. It starts with phase 1, which is basically background research, digging through old records, maps, photos. If that turns up any red flags, they move to phase 2. That's when they actually go on site, drill for soil samples, and send them to a lab. If the lab confirms there's contamination, then it's time for phase 3, which is where they create the official cleanup plan.
Okay, so we've gathered all this evidence. We've done the forensic work. Now for the payoff. This is where we get to see how all those clues come together to build the final design. Every piece of data starts to dictate the shape, the orientation, and all the features of the new building.
Just take one single clue: climate. In a hot, dry region, the design is naturally going to want to create shade and promote cooling, so you'll often see buildings that turn inward and create courtyards. But in a cold region, it's the exact opposite. The building will be compact to minimize heat loss, and it'll have huge windows facing the sun to soak up as much of that free heat as possible. Same problem, two totally different solutions, all driven by the clues from the site.
Or think about a clue like rainfall.
When you put a building in a big parking lot on a piece of land, you create a lot of hard surfaces where rain can't soak in. So a smart design responds to this with stormwater management. It uses things like vegetated swales, green roofs, or even special permeable pavers that let the water soak through. It's all about managing that runoff, preventing erosion, and letting the water get back into the ground naturally.
Even a clue like topography, the slope of the land, gets translated into very specific design rules. A paved parking lot needs a pretty gentle slope, around 2.5%, just enough to drain water without being too steep. A grass lawn can be a little steeper, and an accessible ramp has a very, very strict maximum slope. These aren't just guesses. They're precise responses to the physical data.
And this number right here, 1 to 12, is a perfect example of a regulatory clue in action. It means for every 12 feet, or inches, or meters you go forward, a ramp can only rise by 1 unit. This isn't just a design suggestion. It is a rule that ensures absolutely everyone, regardless of their mobility, can access the building. It's a clue that dictates design for the sake of equity.
Ultimately, this whole investigation, it all leads to this one core philosophy. The best design isn't about forcing an idea onto a piece of land. It's about listening to the land, understanding its physical, its cultural, and its regulatory story, and then creating something that works with its natural characteristics as much as you possibly can.
So now you know the secret language. You know to look for how a building faces the sun, how it handles the rain, how it fits into its neighborhood, and how it respects the land that it's sitting on. The whole story is right there, just waiting to be read. So, what clues